Hello and welcome to today's lesson on nuclear energy. Today we will begin to understand what nuclear energy is and learn the processes of nuclear fission and nuclear fusion, understanding the key differences between them. We will also recognize the applications of nuclear fission in power generation and the potential of nuclear fusion as a future energy source. So far, we have delved into the broader unit of energy, focusing on the various forms it takes and how it can transform from one type to another. We have explored concepts like kinetic and potential energy and the laws of energy conservation, providing a solid grounding in the basics of energy. Building on this foundation, we can now introduce the concept of nuclear energy, which will advance our understanding of physics. By examining nuclear reactions, we can appreciate the immense power stored in atomic nuclei and the significant energy transformations that occur during these processes. Nuclear energy is a powerful form of energy stored within the nucleus of atoms, the tiny core at the center of every atom that contains protons and neutrons. This energy holds together the protons and neutrons within the nucleus of an atom together. It can be released through two main processes: nuclear fission and nuclear fusion. In nuclear fission, the nucleus of an atom splits into smaller nuclei, releasing a large amount of energy. This process is typically initiated when a heavy nucleus, such as uranium-235, absorbs a neutron. The added neutron makes the uranium nucleus unstable, causing it to split into two smaller nuclei, releasing a substantial amount of energy. The energy release in fission is due to the conversion of a tiny amount of the mass of the nucleus into energy, as explained by Einstein's famous equation E equals mc squared. We will further explore the exact process in an upcoming unit. In contrast, nuclear fusion involves two small nuclei merging or fusing together to form a larger nucleus. This process releases a tremendous amount of energy, far more than fission. In fact, fusion reactions release so much energy that they power our sun. Let's apply the processes of fission and fusion. Nuclear fission is the principle behind nuclear power plants. These plants harness the energy released from nuclear fission reactions of heavy elements, like uranium and plutonium, to generate electricity. Inside these plants, controlled fission reactions produce heat, which is used to generate steam. The steam drives turbines connected to generators, which then produce electricity. This provides a significant source of power without the need for burning fossil fuels. Now let's look at nuclear fusion. In the sun's core, hydrogen nuclei fuse to form helium, releasing vast quantities of energy in the form of light and heat, which we receive on Earth. Fusion releases significantly more energy per reaction compared to fission, and it has the potential to be a nearly limitless and clean energy source. However, achieving the conditions necessary for controlled fusion on Earth is technically challenging and is still being researched. We will delve further into this in a future lesson. In summary, nuclear energy is the immense power contained within the nucleus of atoms. It can be liberated through nuclear fission, where atomic nuclei split, or through nuclear fusion, where nuclei merge. Whether in nuclear power plants on Earth or in the fusion processes of stars like the Sun, nuclear energy plays a crucial role in our energy landscape and the universe. Understanding these processes is key to harnessing and utilizing this powerful energy source effectively and safely.